Hey guys, this is Maths Guy channel here, and today we're going to be going through general solution. So like I said, actually with the unit circle, I should put a picture of it every time. But unit that has a cycle of 2 pi, and that some solutions will be the same. Like example, if I say sine of pi, the answer for sine of pi is the same. Sine of 3 of pi, sine of 5 of pi, and sine of 7 of pi, etc., etc. And this works for cos and tan as well. So I'm going to be going through examples. And sort of rule that dictates the cycle is known as the general solution. And that's what we'll be going through today. Okay, so for the first example, if questions asking you to solve sine of theta equals a, where a is greater than 0, so if a is greater than 0, it means it's between quadrants 1 and 2, because sine is positive in quadrants 1 and 2, because that's the y value. So if in quadrant 1, theta is the inverse sine of theta, and quadrant 2, it's pi minus theta of the angle. And to put it simply, the general solution, which is the rule for sine, is that if theta is 2 pi of x plus sine of x, so this should be n for consistency, n plus sine inverse of sine a, or theta equals 2n plus 1 multiplied by pi minus sine theta a. So n is z, so n is a set, is part of the z, so z here is for the integers, so positive whole numbers like 1, 2, 3, and a is between negative 1 and 1. And as discussed in the unit circle, that's the only solutions that can be accepted. This is sort of a visual proof of that. So quadrant 1 here, it's positive on the right side, and quadrant 2 it is quadrant 2 is a negative. So this positive part, this is the negative part here. Okay, example 2 is in cos, instead of sine we have cos. So we have cos of theta equals a, where assuming a is also greater than 0, then theta, in quadrant 1, theta is the negative, is the inverse of cos of theta, not a. And in quadrant 4, it's 2 pi minus theta. And so the general solution for this would be theta equals 2n pi plus minus cos, the inverse cos of theta, where a is nz. Oh, sorry, no, it is a. Yeah, when n is part of z again, so z is the opposite of integers, and a is negative 1 and 1. And so here this shows you the plus minus, because the difference, the theta is related to the x, and quadrants 1 and 4 are where cosine is positive. And lastly, we're going to be going through tan. So if tan of theta equals a, then in quadrant 1, theta is the inverse of tan, and quadrant 3, it's pi plus theta. And theta, the general solution is theta equals n pi plus the inverse of theta a, where n is z, so subset of positive, they're integers, the positive whole numbers, and a is a subset of r, the capital R is the real numbers. And you can take negative values. And here it says n pi because of the example. So this is, for example, this is pi on 4, for instance. This would be 5 pi on 4. This would be 9 pi on 4, 13 pi on 4. That's why it's n pi, adding on each time. So adding one cycle of pi. Well, that sort of makes sense. And this is a bit of a short video, but yeah, that'll be all.